Swayam Prabha. Digital India. Educated India.
Welcome friends to our NPTEL MOOC module on health economics. We have been dealing with this week with the discussion on health efficiency, as we have already clarified the different concepts of efficiency, and in this lecture we will be discussing largely on data involvement analysis. We have already given you the background of DEA in the last lecture. Now we are going to give you further details and their models, how mathematically they are constructed and explained with clarity. Hence, here we will be discussing on input and output CCR model, which we already discussed here, and we will be explaining you the slacks in CCR as well, and their conditions on efficiency scores and slack values. So, let us go back to our previous lecture in a minute, and we discussed the basic DA, especially we emphasize on data driven approach. We discussed DA assesses efficiency in 2 stages, and we especially in data driven approach we have discussed non-econometric and or non-parametric model, and the DE especially assesses efficiency in 2 stages. One is through your input or output orientation, and second is assigned an efficiency score, that is basically called piecewise linear envelope model. And in the third input orientation model, we emphasize on how to keep output fixed and explore the proportional reduction in input usage, which is deriving the best output or output to be fixed and optimizing the use of inputs. That is called input orientation model. In the output orientation, it is just the reverse, keep the input to be constant and explore the proportional expansion in output, and how these are discussed in detail we will clarify further. In the basic DEA model, we start with the orientation, that is because maybe of input oriented or output oriented. And the input oriented, we have the model through the CRS or the variable returns to scale model. In the CRS we have CCR model. CCR stands for from the names of the authors who have started, Chance, Cooper and Rhodes CCR, and follows CRS, that is constant return to scale model with their assumption, and VRS actually variable returns to scale, where it was initially introduced by Banker, Chance and Cooper, that is why it is called BCC. And in the output model, again through the output orientation model, we can have CCR and also BCC model. And sometimes in CCR, like CCR I said Chance, sometimes it reads as Cans as well, Cooper and Rhodes. So, you can also follow it accordingly. So, through the CCR we will discuss their input, CCR inputs and or BCC input, and similarly in other cases CCR will in the output orientation we will be emphasizing on the CCR output and BCC output. There are other models especially emphasized as called additive models and weight restricted models, also called multiplayer models. And the last mostly also discussed in the paper on slack based models. We will be also explaining which are called slacks. Let us start with that CCR model. Is the first model introduced in 1978 based on Farrell 1957. Later on CCR of 1978 is noted, and they assume CRS function, constant return to scale production function. DA forms a frontier using the efficient organization. So, and originally assumed input orientation, which we have already started. Later even they were extended to output orientation model as well. That is, Cooper et al. 2007 paper suggests that to have adequate number of degrees of freedom, the n, the size of the n should exceed the number of inputs and outputs by several times. This is also considered as a rule of thumb, n must be greater than that of inputs and outputs. Okay. There are different formulation and estimation based on three forms of CCR. We start with the ratio form. The ratio form where it measures efficiency in the ratio form, and this is also called fractional form. And in the input oriented model where CCR input is written, CCR we already clarified, where in the ratio form the attempt is to maximize, or the maximization of ratio of weighted multiple outputs to weighted multiple inputs. Basically it is weighted, basically it is output to input, and its weights, respective weights are taken, respective weight of output and inputs are taken. This is subject to the ratio of other DMUs. Other DMUs, basically the particular DMU which we have started explaining for their output and inputs. So, the sum of other DMUs must be less than 1, then only we can discuss the possible optimization level through the input oriented model. So, this is how it is explained. So, the attempt is to the theta refers to the maximization of output to input. Okay. So, here y stands for the output and x stands for the input. Output variables, and there might be rth number of output variables. Even for the respective DMUs of the or stands for the organizations or DMU. So, and the respective weights are U and V, okay, for the output and inputs respectively, subject to other DMUs. There are some of other DMUs with their output to orient to that of the inputs, or their efficiency ratio that must have been less than that of 1, because we have clarified very clearly that the optimum level reaches at 1 in terms of ratio. Therefore, J here stands for other DMUs. Okay. So, I am just giving you the direction. This is actually called other DMUs. All right. So, the weights, respective weight must be positive, okay, for all R and ith, rth level of output and ith level of inputs. Hence, our objective function is highlighted here. This is to maximize the efficiency ratio subject to the constraint of other DMUs. Okay, we have just clarified this is precisely called ratio form. U and V are respective weights of the decision variables, and the optimum value of U and V is the solution for the efficiency ratio. Okay. Next, in the ratio form, while you are going through the input oriented model through the CCR, where now we have just mentioned once again that this theta of the O, or O stands for the organizations or the DMO unit of the organization. This is precisely called the efficiency score. This must be at maximum of till 1, 0 till 1. If it reaches till 1, that means the efficiency score is considered to be the best. Okay. Hence, a group of other DMOs that must be accounting for that is for j till the n. Okay, that must be less than 1. Why Rj stands for rth outputs produced by the DMOs. Okay, DMO j, so those must be till 1 till s. Okay, and xij, that is ith inputs of DMU j, that must be till 1 to m. U and V should be positive, and number of constant varies to the number of DMUs, and the weights are derived from the data and used to be considered to be endogenous, and from the model itself we will identify. So, in the optimization problem, this gives most favorable weights to DMOs, that is the Oth unit, that constraints allow weights the best possible weight to be identified, and no other sets of weights leads to higher level of efficiency. This means that the input output ratio for each DMU is maximized relative to that of other DMOs. So, as a constant function, we have clarified that these DMUs is comparatively better than that of all other DMOs. Now, coming to the multiplier form suggested by Kerners and Coopers, they suggested to transform the ratio form. Since ratio form is considered to be complex because it is considered number of infinite solution, okay, and usually since it is fractional in nature, and whereas in the multiplier form it is attempted to simplify the procedure and taken a linear function, and also called primal linear programming. This also follows the input oriented format. Hence, the equation is maximizing that theta. Theta stands for the efficiency score, okay, and that's basically a linear combination of its respective weight of the output, okay, of the DM unit, okay, and rth number of output of that of the DMUs, and subject to the gap between output to input, okay, and the sum the additional value of the with their respective weights of the output or the jth jth units of output to that of jth units of inputs, that must be less than 0. It should not be positive, okay, the gap should not be positive. And another condition is that the respective weight of the ith inputs that must be equal to 1. Input and its respective weight value summation should be 1. So, here we have to note that it is not just the constant that is of nth unit now, because we have taken another constant function. So, the number of constant increased to n plus 1. Ratio and multiplier form considered to be equivalent in nature, okay, and notations we have taken as per the previous model. The most important usage of the efficiency score is through the development, the envelopment form. The envelope we have already mentioned in the earlier lecture that it envelopes the scores, okay. We will clarify this, and we will just comparing the multiplier form which you have just discussed. The objective function was to maximize, wherein the envelopment function it is to minimize the objective function, since it is the input oriented model, okay. And again here the constraints are to out of the mth input constraints, the efficiency score times its the mth inputs, that is the maximum score possible in case of inputs. So, lambda times its xij should be less than that of the maximum score. Then in case of output also, we since we get the input score, the minimum minimization of the input score through the envelopment form. So, the output this must be less than that of the output of the DME unit, okay, and must be greater than that of others, must be greater than that of must be, since we are saying this number, the others are actually in terms of output, that must be greater than. In the output oriented, we will find just the reverse. Okay. So, and here you need to note that the number of output constants has to be till s, and then what is this lambda of the jth unit, this has to be positive or non-negative constants. Now, I will clarify further that these lambda is basically the raw weights assigned to the peer DMUs. And again, since we have taken the summation of with their respective weight, we are actually modeling through the linear program, and there are dual formulations as well, and this seeks efficiency by minimizing the efficiency of a focal, that is the DME unit, OAT unit, subject to two sets of inequality. First inequality emphasizes that the weight sum of inputs of the DMUs should be less than, which we have already said, less than or equal to the inputs of the focal DMU being evaluated. The sum of the other DMU and their inputs must be less than that of this. Where in the second inequality, we identify the constant function with respect to the output. The inequality asserts that the weighted sum of the outputs of the non-focal DMU should be greater than, should be higher than that of the respective focal DMU. Okay. As I already discussed, there must be some slacks. Slacks basically will identify the best, the optimum combination of inputs or in the output model as well. We will find out which one indeed the best. Slacks exist if at least one input could be reduced further without using other input, or if at least one output increases given the level of input. Okay. With the same input we can increase more output, or with the same output we can reduce the input, that basically called slacks. You can easily see the we know that this is not the optimum one for sure, so far as inputs are concerned, okay, and this is precisely A prime is considered to be the optimum one, but the best one or not, we can clarify further. So, basically with the lower inputs of these, still we can able to attain the optimum level of output. Therefore, this is called input slack, x2 can be minimized. Similarly, you can explain for the x1 level as well. And so, A prime C is called input slack. Similarly, in case of output slack, here the variables should be just the reverse. So, we know that the output A prime to C, A prime is also optimum and C is also optimum, but the best one is that we can actually minimize our or maximize output with the given level of output or the given level of what inputs. Okay. So, this is what is called A prime to C, amount by which output y1 okay, can still be expanded. Okay. So, here this distance corresponding to this distance and to this distance, this can be expanded with the same level of inputs. Okay. So, in the envelopment form, only technical efficiency scores are discussed. We have already discussed earlier what is called allocative efficiency and technical efficiency. Here in the envelopment form, we are emphasizing on the technical efficiency aspects. This does not account the slacks in the basic form of envelopment analysis. This fails to account for slacks or sometimes overestimation of technical efficiency as per the Farrell estimates for those DMU units operating with slacks. So, now you can understand what is the relevance of other advanced models, since slacks are not clearly accounted by the envelope form. Various ways of dealing technically with slacks, such as Besant et al. In 1988 paper, Togerson, Forsund and Kittelson 1996, Tofelis 2001, etc. They have also discussed. In 1993 paper by Ali and Seyford proposed technical efficiency by means of a second stage DA linear programming problem. This is done by taking the theta value from the first stage linear programming problem. Actually, in the second stage we can identify whether still their change is positive or 0 or negative, and accordingly you can identify the slacks. Running a second stage linear programming problem and setting the input and output slacks to 0, okay, can understand accordingly whether it is output based slacks or input based slacks. Model of slack have two phases. Phase 1 obtain or theta star for organizations that is DMU unit U or organization of O from the envelopment model. This is how it looks like. We have started with the envelopment form, hence our target is of minimize theta, subject to the basic envelopment form we already clarified. Its input constraint, output constraint and non-negative constraints. So, this is the first stage. Second stage, as I already mentioned, we will maximize the slack. Okay, it is related to slack. First one is the basic envelopment form. Second one is the maximizing the slack. So, maximizing slack with respect to slack positive, okay, and slack negative. Ith unit and its for rth unit we can also check. Ith unit of inputs we already mentioned, and slack might be in terms of inputs and slack might be in terms of output. Okay. So, if it is input based we have mentioned as minus, and output based it is positive, okay, more towards more output with the same inputs. Okay. So, then subject to it is again with the same modified version of the constants, okay, where slacks are actually mentioned. Okay, all right. And you can just see the changes, and rest are almost this is related to the inputs constants, to the output constant, and accordingly we can identify its maximization sports. So, now here it is given as very clearly defined, minus it is written as input slack and plus it is output slacks, and theta star is basically which we already discussed as a D efficiency score resulting from the initial run. First theta will derive the initial calculation, and then based on that we can restrict it to its constant function. Okay. And we have to clearly mention that this superscripted minus sign on input and plus sign is on output, and that is related to slacks, and superscripted minus sign on input slacks that indicates reduction. Okay. Slacks means basically, therefore, in the input context the objective is to actually reduce, okay, hence it is a negative one. Where in case of positive sign Objective is to actually increase the output, hence it is augmentation of outputs. So, with the input model through the CCR which already we started, again with slack, in the initial model we did not discuss with the slack. Now, the minimization of efficiency score minus sum of its slacks. Okay. So, basically this is the efficiency score which already said minus what is this slacks, right, and if it is input or oriented. Rest are almost the same, okay, and can have a change. Then okay, I will just clarify. We already discussed what is called efficient DMUs and what is called full efficient DMUs. Again we can see C and D, if you just compare these in the input oriented model. Our input orientation is defining very clearly that C is actually called a fully optimized or a fully not optimized efficient score. Okay. So, DMU D on the isoquant is called efficient with have a efficiency score 1, but not Pareto efficient, since we can able to also reduce the X1 content to reach at the 1 level of efficiency score. Okay. Not Pareto efficient because we can able to reduce input X1 without using X2. Efficiency of 1 or 100% for a DMU does not necessarily mean it is Pareto efficient, but converse is actually true. Fully efficient and weakly efficient DMUs, we have clarified already. The performance of DMUs can be assessed either as fully efficient or weakly efficient. Conditions on efficiency scores and slack values. Okay. So, what are the conditions to reach at that fully efficient level and weakly efficient cases? So, here the condition is that the fully efficient it has to be 1, or even in the another case that is also with theta star also be 1, and with input slacks that has to be 0, and even output slacks it has to be 0. In weakly one other same, where in case of slacks at least one input, okay, should be non-zero, which the constant we have already discussed in our model. And in another one, in the output case at least one or rth output should be non-zero. In input oriented CCR models, labels of efficient targets for inputs and outputs. So, targets, so some target has to be discussed, efficient targets for the inputs and outputs. So, as we already said, the target is from one level to another level. In case of inputs, the target is to actually reduce from the efficient till the slacks, the negative content should has been reduced. Therefore, minus is actually given. Where in case of output it has to be added, more positive slacks should be added to the output. Okay. Therefore, a target symbol is given, and every time we have discussed with the rth level of rth level of output or ith level of input. Okay. So, CCR input so far we have discussed in detail. Now, in short CCR output based oriented model, we use phi. Okay. Phi, in that case phi is basically maximize. In usually we said it in the DA formulation or the envelopment formulation. We discussed with minimize function. Now, we are actually discussing the maximize function, since it is output oriented. Rest are precisely the same, okay, precisely the same, you can easily follow. And however, we have also discussed this, the efficiency emphasis is removed from input and placed into output. That is basically the second constant in that case. So, you can just have a check, and efficient target calculation for output oriented CCR model. Again, in case of target calculation, you can just have a check. Here we have also identified, and this is how is very clearly discussed. So, these are all so far as DA and its extension are concerned. We will be also giving you further directions related to its applications in our next lectures. Okay. So, these are the important readings for your preparations, and I think you will have number of queries and we will be happy to address it in our query section. Thank you. Before thank you, I think I should clarify what is there in our next lecture. We will be discussing on BCC model, because we only discussed so far the first one. This is the one, CCR, isn't it? So, the next one we are discussing BCC model and the other econometric measurement of efficiency. Okay. So, with this I suggest you to follow our next lecture for further clarification. Thank you.